Dr. Sohail, if you could share your screen and start presenting. Dr. Sohail, if you could start sharing your screen. You are not audible. Could you unmute yourself first? Yes, now you're audible. Yeah, you could move to the PowerPoint and then start the slideshow. Slideshow, please. Perfect. Let's start, sir.
Fine. Am I audible?
Yes, yes, yes.
Okay, then we will start.
Sir, we can start. You're audible, sir. You're audible. You can start.
1 minute. Just give me 1 or 2 minutes. Are the slides visible? Dr.
Yes,
Mark?
yes, sir. Yes, yes, yes.
Okay. Should I start?
Yeah, please start. Yeah, please start.
At the outset, a very good afternoon to all. I express my immense gratitude towards the organizing team, including my dear friend, Dr. Arisha from NADCL, the technical team, ably led by Majid Nisar and Hamida Madam, and I can see a lot of participants from across the country who are attending this workshop. I hope the inaugural was very good and it went on smoothly. So the first lecture is a very important one. It's related to sustainable livestock production, as you can see from the topic. And I am going to deliberate on what are the various fodder interventions or fodder innovations, you can say, that are available with us so as to achieve the goal of fodder security or nutritional security for our livestock. And also, this should lead us to achieving sustainable development goals of the United Nations, and also environmental sustainability or environmental health, which is of paramount importance. That should also be our objective while we develop any type of fodder innovation or intervention. Now the question arises, what is the need for various fodder innovations or technologies? As you know that the livestock sector represents around 1/3 of agricultural GDP in most countries, and in our country also, it roughly contributes about 27 to 28% to the national GDP. And in some states, it contributes more than 40% to the state gross domestic products. And in hilly areas like Jammu and Kashmir, Uttarakhand, Himachal Pradesh, UT of Ladakh, it contributes more than that. But the problem, we are number one in livestock population. We are number one in milk production in the world. But there is low productivity of livestock. Uh, the average milk production per lactation, if you see those figures, it's very short of what is being observed in various developed nations. So it's 30 to 40% short of that global average, especially if we talk of developed nations. And the prime factors that are responsible for low productivity of livestock or fodder deficit, it accounts for 50 to 60%. Then other factors including breed improvement or genetic improvement, then health management is also one issue. And coupled with this, we have limited land endowments. If you see the land use pattern in our country, the area under fodder crops is 4% of the total geographical area. It's very less. It has remained static for the past several decades. So because farmers, they don't earmark adequate land for fodder cultivation. They Farmers are more likely to apportion adequate land for cash crops or for horticultural crops like fruits and vegetables. But fodder crops, we call them as orphan crops because uh, not much land is earmarked for this uh, for fodder cultivation, which is a very important factor so far as livestock production is concerned. So the possibility of increased forage production by bringing additional area under fodder cultivation, it seems the options are limited. So therefore, we have to make continuous efforts to augment forage resource availability through various niche areas. And what niche areas available with us, we will be elaborating further in the slides. And if you see, this is a very healthy trend. It presents also opportunities and challenges equally for livestock production systems. Globally, there has been a greater demand for livestock products as human populations have increased enormously. And in our country, I think in the next few years, we are going to be number one so far as human population is concerned. And because of the dietary preferences have changed, our food plate has changed. There is increased production and consumption of livestock products, and it will grow day by day, and it has been projected to grow at the rate of 3 to 5% per annum. And it has been projected that by 2050, total meat and milk consumption in developing countries is expected to at least double. So, if you can see from this figure, although it is from 2014, but the values are for 2012. So, you can see that 4 of 5 highest value global commodities, they are from livestock. And the trend will be equally, I think, as of now, we might have maybe more than uh, 10 high value global commodities from livestock. Now, this I have already told you that the livestock contribution to agricultural GDP is 25.6%, and the trends have already been discussed. This is the projected livestock population for 2050. Then this is the species-wise, for example, milk production in our country. This is a very important slide, which is from Indian Grassland and Fodder Research Institute Vision Document of 2050. You can see there is a widening gap between the demand and supply of fodder, both in terms of dry as well as green. And if you see of 2020 and 2030, the deficit in, say, for example, green is 30.65%, while as by 2030 it is 24%, and the deficit for dry fodder production, it's 11 point almost 12%. These are the grazing resources that are available in our country. Forests contribute 22.7% of the total geographical area, followed by common property resources other than forests as and permanent pastures, grazing lands, cultivable wasteland. These are the available niche areas that I was talking about in the second slide, that we have to augment forage resource availability from these particular resources. And you know that feed and fodder are the major important inputs for any livestock production system, as they represent 50 to 75% of the total cost of production. And in our country, as I already told, that milk production in India is increasing at a faster rate, but feed and fodder resources are depleting due to increased human population, increased livestock population, urbanization, and the pressure on land to grow cereal and cash crops. So this has led to qualitative and quantitative insufficiency of feed and fodder resources. And this I already discussed that we have low productivity of livestock, and the responsible factors are these, and the feed and fodder deficiency account for 50 more than 50% for this livestock production. If we see that in our country, the fodder scenario is very good in some in a few states, but in if we see the picture at the national level, it's a little bit skewed. We have fodder deficiency so far as green as well as dry fodder is concerned. And the important fodder crops in, say, for example, Kharif season, we have non-legumes like maize, sorghum, pearl millet. Then in legumes, we have cowpea, we have cluster bean. In Rabi season, we have oats and barley. And in legumes, we have berseem and lucerne as the predominant cultivated fodder crops. And we have also some perennial grasses like NB hybrid or Guinea grass, Staria, tall fescue, dactylis, and so many other fodder crops. In perennial grasses, we have also perennial legumes. So a multi-pronged approach for increasing fodder production is needed. We have to develop strategies to increase forage production per unit area. We have to encourage forage production in mixed farming systems. We have to exploit wastelands. There are a lot of wastelands in our country, denuded, degraded, and marginal and sub-marginal lands for the development of pastures and forage-based agroforestry systems like hortipastoral systems or and silvipastoral systems. And strategies are also needed for efficient utilization of available resources like crop residues, non-conventional feeds and fodders. And there is a need at national level that we should have a national fodder mission. So now I'll be giving you some details about various fodder crops in our country. What are the varieties that have been developed in these crops, and whether they are of multi-cut or single cut or double cut? What is the seed rate and sowing, and what are the management practices that are to be followed in these while sowing or planting these fodder crops? I think I will be sharing the lecture notes with you. So if I give this example, I will be running through the slides, forthcoming slides. But if we talk about sorghum, it's a very important kharif fodder in our country. It's a millet as well. We have single cut varieties like PC-6, twin PC-9, PC-23, HC-136, and so forth and so on. Then we have double cut varieties like CO2-27, and we have multi-cut varieties are also available in this, like Methi Sudan, MP Cherry, Pioneer 988, Hara Sona, and the seed rate that is what to be sown on per hectare basis is 35 to 45 kgs, and the sowing preferred sowing time is from March to August. The spacing is to be followed is 25 to 30 and 10 is to 15 centimeters. The nutrient requirement is also given for single cut, double cut, and multi cut types. Then since weeds do come in our cultivated fodders, So the option for weed management is also given. What are the various weedicides that are available, and at what rate they can be sprayed. Then information about some important pest and diseases of this sorghum is also given. So then at what time we should harvest the single cut varieties or multi cut varieties. In single cuts, the yield is 300 to 500 quintals per hectare, and in multi cut varieties, the yield is more. It is 500 to 900 quintals per hectare. The similar information about pearl millet, which is also a very important fodder crop, especially in arid areas like Rajasthan and Gujarat. We also have in this particular crop single cut, double cut, and multi cut varieties. The information I'll be sharing in the form of lecture notes with you. I don't want to repeat all about the seed rate spacing, nutrient management, and pest and disease management. I'll be sharing the notes with you. So another fodder crop, kharif fodder crop is maize, and you know that at all India level we have J 1006 Pratap Makka, then African tall, and a very recently developed variety for North Hill Zone, that is KDFM1 from Sher Kashmir University of Agricultural Sciences and Technology of Kashmir. Similarly, we have certain legumes for Kharif season, like cowpea. We have different varieties released for different zones, like hill zone, northwest zone, and all India level varieties, like Bunde Lobia 1, developed by IGFRI, Bunde Lobia 2, this is for northwest zone. Then weed management, nutrient management information is also given. The another fodder crop, leguminous fodder crop, is Cymopsis tetragonoloba. This is guar, known as which is very much grown in Rajasthan and neighboring states. Then coming to various fodder crops which are very much suitable for Rabi season, we have very important cereal forage in the form of oat. In oat also, we have varieties released for different agroclimatic zones, and we also have varieties that are single cut and multi-cut types. Other information is also given. In single cut, for example, 300 to 400 quintals per hectare. In double cut, it is 400 to 500, and in multi cut, 500 to 600 quintals per hectare. Another legume which is very important for in to be grown in Rabi season is Trifolium alexandrinum, that is berseem. So the varieties that are available with us, Meskavi, Vardhan, BB2, UPB 110, JB 123. All the information is given, and the yield potential is also very good, 700 to 1100 quintals per hectare. Then Rizka, which is a very important legume in peninsular India, in Karnataka, Andhra Pradesh, Gujarat, and in some parts of Rajasthan, and also in cold arid zones of India like Lahore, Spiti, UT of Ladakh. Varieties that have been developed for various agroclimatic zones, the list is given, and other information is also given. Then coming to perennial forages, Bajra Napier hybrid, which is a cross between Penicillium glaucum and Penicillium purpureum, that's elephant grass, and pearl millet. We also have a lot of varieties in this particular grass, and this grass, as of now, is regarded as king of forage crops because of its enormous yield potential, from varying from 800 to 2000 quintals per hectare, and it can be propagated through rooted slips or cuttings. Then we have another grass in perennial type. We have Panicum max. We have Panicum maximum, that is Guinea grass, and we have two varieties that have been released from IGFRI, that is Bundel Guinea 1 and Bundel Guinea 2. We have another type of Guinea grass, that is grazing Guinea, which is very much suitable for growing as intercrop in our orchard or plantation crop systems like coconut, areca nut, and mango. Then coming to what are the production technologies so far as our arable lands or cultivated lands are concerned, and what are the production technologies that are available with us so far as non-arable lands or non-cultivatable lands are concerned. So first, I will be giving some details about arable lands, that cultivated lands. For example, if you see that our institute at IGF or IJANSI has developed this particular system for irrigated uh, areas. In this system, we can grow sorghum in as a kharif crop, which is preferably a multi-cut one, uh, plus intercropped with cowpea, and during Rabi we can grow barseem crop. So the BC ratio is very good. It can support 5 to 6 adult cattle units per hectare basis, and it's very much suitable for peri-urban and milk-shed areas in whole of India except South India. Then another option we have in irrigated arable lands is a perennial based, and the previous one was annual based. In this, we can have Bajra Napier hybrid, and in between the interspaces, we can have cowpea during Kharif and Barseem during Rabi. Any of the variety which I gave details about a few slides back. Then the production potential is very good. It's 273 tons per hectare per year. But the green fodder, if you see, it is 40. This is about green fodder, but if we see its potential on dry matter basis, it is 44.3 tons. Then coming to fodder production in rain-fed arable lands, rain-fed cultivable areas, we can have sorghum as grain crop, followed by and intercropped with cowpea during kharif seasons. And so far as rain-fed arable lands are concerned, if we talk about a perennial-based system, we can have subabul, which is a fodder tree, and we can have another important forage crop, that is tri-specific hybrid, which is a hybrid between Penistum purpureum, Penistum succumulatum, and Penistum glaucum. This is a very important fodder crop. And sorghum, we can also raise sorghum in Kharif season. Also, we can have pigeon pea in this system. This system has been developed by our crop production division of Indian Grassland and Fodder Research Institute. And also, we can get green fodder at the tune of 30 tons and silage at the rate of 15 tons per hectare. Then coming to non-arable lands, we don't have much option in arable land, but we have a lot of options in non-arable land. As in the slide, I showed various grazing resources that are available in our country. We have so much of options available in this category. For example, we have silvopasture systems, and our institute has developed a number of systems like ficus-based silvopasture system, mulberry-based silvopasture system, acacia-based silvopasture system. And if we talk about, say, for example, ficus-based silvopasture system, the dry matter production from trees is 10.2 tons per hectare, and the dry matter production from pasture it is 26 tons per hectare. The BC ratio is very good. And besides fodder, whatever fodder we are getting from this particular system, we are also getting soil carbon sequestration from this particular system. So besides providing provisioning services, this system also provides us other ecosystem services in the form of mitigating climate change, and the eco restoration efficiency is also very good, because these systems are very much suitable for degraded, denuded, or uh, degraded lands. Then we also have certain options so far as utilizing uh, interspaces in the fruit orchards. Say, for example, amla plantation or guava orchards or mango orchards or apple orchards or almond orchards. We have a lot of interspaces available between the trees, and we can use this particular niche area for augmentation of forage resources. And this system not only provides us fodder, from the interspaces. It also provides us fruit. So there is diversification of output. It also provides us firewood in the form of grounded wood biomass. It also provides us leaf. Say, for example, in of apple leaf can be used as fodder, and also it helps in moisture and soil conservation because runoff will be less. It also helps in augmenting the soil fertility of the orchards. But we have to be very careful while developing this particular system because our intercrop should not damage our main crop, that is apple or any other fruit crop. So we have to devise this system, and it is advocated to follow Swiss sandwich system that in a orchard alleyway, there are two types of rows. One is the fruit tree row, and another one is the interspace row. So fruit tree row, we can have, say for example, in each row, on either side of the line or the row, we can have cultivated portion. We can have tilled portion. We can till that area so that so as to keep that row as weed free, but the interspace area that is left with us, we can raise fodder crops in that. So, for example, our station at Srinagar, J&K, we have developed almond-based systems, and we have also developed mulberry-based silvopasture systems. Then we also have one regional station at Dharwad in Karnataka. So there we had a program of using mango orchards and plantation crops as niche areas for augmenting fodder production. So we used certain fodder crops like perennial fodder sorghum. The variety is COFS29. Then Bajra Napier hybrid, Guinea grass, BG1 and BG2. And the benefits, you can see that there is the green fodder shortage was reduced from 56% to 17%. Then you might have heard about moringa, which is a very important crop. Uh, uh, Sometimes it's used as a tree crop, or if we go for pollarding or some systems, it can be also used as a shrub. So this crop is very important, and it is having also medicinal value. It can also be used as a fodder source, and the package of practices is given. What are the various popular varieties that are available with us in this particular crop, that is PKM-1 and PKM-2, and the green fodder production potential is 800 to 1000 quintals per hectare. So fertilizer management, weed management, then what is the spacing that is to be followed, is all the information is given. And the crude protein, if we compare moringa, napier, and fodder sugarcane, for example, the crude protein in moringa is very good. It's 21 to 23%, while as in napier we have only 8 to 10%, and in fodder sugarcane we have 10 to 11%. Then this is again Hardwickia binata Anjan based silvopasture system. We also can adopt some soil water conservation measures in the form of staggered trench or pits. If we see the while we are using trees, shrubs, and grasses together, that is a three-tier silvopasture system. So we can have a lot of fodder production in this particular. Then we have a lot of bunds in our country, in the paddy fields, in the wheat fields. So we can use that bund area for cultivating forage crops. For example, in if you see this slide, uh, the category of farmers is given, the number of holdings are given, and the total bund length in million meters is given. In the marginal category, for example, we have 11,391 million meters of bund available with us. Similarly, for other categories, all it is given. And we can use some perennial grasses like NB hybrid, tri-specific hybrid, Steria, Guinea grass, Polaris aquatica, Dactylis, tall fescue, and it can give us 7 to 11 quintals green fodder per 100-meter boundary per year. So if 10% farm bunds are utilized, we can get additionally 17.8 metric tons green fodder production per year. So this is also a very important niche area. This particular system is a non-competitive land use, because otherwise these bunds are not used for raising any other crop. So that's why we call it as a non-competitive land use system. You can see some photographs, Napier Bajra hybrid on bunds at farmers field. Then you know that we have a lot of problematic soils in our country, like saline soils, saline alkali soils, alkaline soils. So crops and varieties that are suitable for these problem soils are available with us. The green fodder yield or potential is also given for all the crops and all the varieties. This is for sodic soils. Earlier slide was for saline soils. These are the crops and varieties suitable for waterlogged soils. Then uh, we had a one project with ICADA. We introduced some spineless cactus in our country. Uh, this is a very important fodder, and you can see the crude protein is 8.33%. Then NDF and ADF are very less, so it's a very good fodder crop for our degraded lands. The work is going on in this particular system, and we have one demonstration plot at our uh, main headquarters, that is Indian Grassland and Fodder Research Institute, Jhansi. Then another important non-conventional fodder crop is azolla. It can be cultivated in pots and tanks. We have several species of azolla folliculoides, azolla microphylla, azolla pinnata, rubra, mexicana, carolinea. Then what is the biomass available with us? So that it can double in, for example, if we see microphylla, it can double in five days. So we can keep on getting good fodder. And this is a very good source of green fodder, especially during lean period when not enough fodder is available with us. And it's a very good source of protein, almost 20 to 22% protein content, and other. It can ensure, say, for example, round the year fodder production in southern states and in northern states in during summer and monsoon periods. Then this was all about fodder production from cultivated, from non-cultivated lands. Then what are the various non-conventional fodder resources? Then coming to fodder conservation. For example, silage production uh, at large scale. We can have this in kacha pits, in pakka pits, in polythene bags. Silage industry has grown tremendously in Punjab and Haryana, like anything. So this is a very important aspect of fodder production. Then Lathyrus as fodder. We have low oxalyl diaminopropionic acid, which is a neurotoxin, but we have some low ODAP varieties like Nirmal and Ratan, and these also can be grown as fodder. Then cactus, I already shared a slide about this. Then fodder sugarcane, because we have certain lines in sugarcane uh, that can be used as fodder, especially sugarcane tops. They are invariably used as a fodder. And in these, we had a project with Sugarcane Institute in Coimbatore. We got some lines from that, and we have evaluated certain and identified certain fodder sugarcane lines. And the crude protein is also very good, roughly about 11%. Then potato haulms, we have a lot of area under potato and peas in our country. And potato haulms and pea haulm can be used, can be ensiled, and it can be used as a fodder. So it's sort of a, I can say, non-conventional fodder resource. Then coming to important, as I already told you that we have a lot of grassland area in our country, a lot of pasture area in our country, but most of the grasslands are in degraded state. So we need to improve these grasslands, because a lot of pastoral communities are dependent on these grasslands for getting fodder. And we have certain very unique and very important ethnic grasslands in our countries. For example, Shola grasslands in peninsular India. We have alpine pastures of Himalayan region. Then we have grasslands of trans-Himalayan region. Then we have Amrapali grasslands in southern region. Then we have Bunny grasslands in Gujarat and Rajasthan. So though the productivity is not good, so we need to increase the carrying capacity of these grasslands by introducing certain grasses and legumes in these grasslands, so as to increase their carrying capacity from 0.55 ACUs per hectare to 2 ACUs per hectare, or maybe more than that. Then we have a lot of fodder tree species in our country, and fodder trees have been identified for all the agroclimatic zones. See, for example, for arid zone, we have species like Prosopis cineraria, Elanthus excelsa, Neem, Ziziphus, Hardwickia bainata, Bohinia variegata, Lucina leucocephala. We can use also silvipastoral systems. So we can use fodder trees or multipurpose tree species. So we can get fodder not only from tree component, but also from the interspecies where fodder crops are grown. Then we have identified certain species for other crops, other areas. So this is also a very good source of fodder for us. Then coming to developing machinery for uh, various fodder production or utilization on conservation aspects, our institute has developed a defluffing machine, because the grass seed is very fluffed. So it affects the germination, it affects transportation. So our institute has developed a defluffing machine, especially in Dinanath grass. So defluffing capacity for fully dried Dinanath grass seed and Sencrus ciliaris, for example, was observed in the range of 7 to 8.5 kilogram per hectare, and the true seed was only 15 to 20% recovery. So this machine saves 76% processing cost as compared to traditional manual developing. Then we also have developed, because in grasslands, I want to mention here that in grasslands we cannot go for uh, similar packages and practices as we do in, say, for example, cultivated fodder crops or in cultivated areas. So we have to go for pelleting of the seed. So for that we need to have seed pelleting machine, and our institute has one division dedicated to this. They have developed seed pelleting machine. So we can pellet the seeds, and we can use that pelleted seed in the grassland areas. And also we can use drones to spread that seed in the grasslands. Then also one of the systems that is very important to develop low cost hydroponic systems also. This is also a very important area where a lot of work is to be done. And our institute has developed one low cost evaporative cool hydroponic unit. And also we can use in, say, for example, in trans-Himalayan region, for example, I will give you an example of Ladakh, where the photo intensity is very enormous. I think we have insolation available for 311 days in a year. There is a lot of UV ray also. So solar panels, solar-based hydroponic systems can be used in such areas, so as to reduce the fodder deficit. Then we also need some seed coating. For example, if we coat the seeds if we pellet the seeds, we have to coat the seeds. We can use some nutrients. We can use some, say, for example, if some pesticides or some insecticides can also be mixed in that. So we need a very automatic seed coating machine. And I'm happy to share that our one of the divisions at our IGFRI seed technology division has developed this automatic seed coating machine for coating of fodder seed. Then uh, these were the several options, and this is This is technology has been developed basically in Israel. So total mixed ration, which uses lot of roughage material, lot of molasses, then silage also can be mixed together. We can develop this total mixed ration together. For example, we can mix minerals, groundnut cake or maize grain, then tree fodder, then whatever, say for example, spent mushroom we is available with us. We can mix that as well, and we can develop the total ration for a particular category of livestock. See, for example, this total mixed ration has again been developed by our one of the divisions, that is plant and animal relationship division, for goats, and the product is also being commercialized through a big center of IGFRI. This was all about fodder production, utilization, and conservation. Thank you for patiently listening to this talk. I thank all the organizers for giving me an opportunity to share some information related to fodder innovations with you all. If any questions are there, I will be very happy to answer.
Participants can raise their hand or and turn on your microphone if they have any questions. Yeah, please go ahead, Dr. Rinkesh.
Sir, any TMR available for large animal?
Yeah. TMR is basically TMR is available for large category of animals. It's available for all the categories of animals. In India, for example, if you see, private companies also sell TMR. But as of now, our institute has developed this TMR for goats only. So they are working for developing it for large animals like buffalo and cattle. Hopefully, in a couple of years, we can get TMR for other categories of livestock.
Okay. Thank you, sir.
Thank you for your question. Any other query?
I don't think there is another question here. On behalf of NADCL and other organizing committee, I would want to thank you, sir, for being with us. Thanks a lot. It's really an honor always and a pleasure always having you with us. Thank you.
Thank you,
Hello.
Majid. Yes.
Cactus variety without spine. Seed is available?
Yeah. Basically, it propagates through cladodes, and cladodes are available with us at our headquarters, which is located in Jhansi. You can contact anytime any of our divisions or our director. I think they will be happy to supply these cladodes at your location. If you need any help, I can also help in that. My contact details are with the organizing team, or you can share the details with the course director. I assure you of every kind of help in this endeavor.
Yep. In a desert area, in other arid area, the
Yeah.
spineless cactus is very good for the animal and give fruits also. No?
Yeah, of course, it is very good for our arid regions and semi-arid regions.
Thank you very much.